All right, problem logistic growth functions. And then we are going to work with an example. And it says using the data in table 1 and assuming the growth is exponential. So if the growth is exponential, that's y equals a times b to the x. Okay? So y equals a times b to the x. It says when will the population of San Jose surpass 1 million persons? Okay, so how would we do that? Well, instead of having y, we're going to change it to p of x is equal to a times b to the x, because we're talking about population. So we have to use the two populations we are given and the 2 years that we're given. So the time between 1990 and 2000 is 10 years. Okay? So we're going to put p of 10 equals a times b to the 10. Now, the a would be the starting point, the start where we started counting the population. So now we have p of 10 equals 782,248 times b to the 10. Well, if we're talking about finding b to the 10, that's 10 years later. What was the population 10 years later? 895,193 is equal to 782,248 times b to the 10. Well, we're trying to solve for b, because if we can solve for b, then we have a general equation which can solve for any time, 10 years, 50 years, a million years, and so we need to solve for that. So to do that, we are going to divide both sides of the equation by 782,248. So we're going to divide by 782,248 and 782,248. When we do that, this goes to 1, and we've got, well, I guess it wouldn't hurt to go ahead and do it. 895,193 divided by 782,248, which gives us 1.144. So this is 1.144 equals b to the 10. Okay? Well, we need to know what b is, not b to the 10. So some of you did it one way and some of you did it the other way. So I'm going to do it both ways. We can take the 10th root of 1.144 would be equal to the 10th root of b to the 10th, or we could say 1.144 to the 1/10 is equal to b to the 10th raised to the power of 1/10. Both of them will work, whichever way you're more comfortable with. So 1.44 to the power of 1/10 gives me 1.037. 1.037. And if I do the 10th root, oops, it gives me 1.0135. So since that's 3.5 and 3.6, I'm going to put it in the middle. That's what I'll put it in the middle, 1.0136. And so here we go. Now we've got p of x is equal to 782,248 times, well, we found it, we're going to say 1.0136 to the x power. Now what it's asking is when will it hit 1 million? So we need to put 1 million in the calculator. So we're going to have 1,000,000 is equal to 782,248 times 1.0136 to the x. The reason these two are different is because we rounded differently. And when you do that, then it gives different answers. So we're just stick with the 1.0136, and that'll give us a good answer. Now, we're going to have to put it in the calculator because at this time we haven't learned how to solve for that x. So if we go to y equals, and clear all these out, and y1, we're going to put the 1 million. And then at y2, we'll put 782,248. Well, helps put in the right number. 782,248 times 1.0136 to the x power. Okay, so we'll put that in the calculator just like that. Now we're going to have to set the window because we don't a million, so we go to window, and we'll put this at 0. And let's go to 25. That may be too much. I don't know. We'll put this at 0. And then a million, well, let's put 1,500,000. And let's put a scale at 1,000. And graph. Well, it didn't give me enough room, so I'm going to have to do it again. Kind of almost did. You can see where it's kind of crossing there, but let's get it better than that. So there we go. So if we do second, calculate 5, enter, 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 that gives us 18.18. So x is equal to 18.18. Now, we started in 1990. So 1990 plus 1818, or we'll just round it to 18, is equal to 2008. So supposedly it'll reach 1 million people in 2008.